Alright, today's section 11-7, circles in the coordinate plane. Just kind of a quick section giving you some skills on how to write an equation of a circle as well as maybe graphing some circles. So it should be a pretty easy section, we're hoping. That's the hope. So let's just get started. The equation of a circle is actually based on the distance formula. Now one of the things you may want to do, because it's going to be helpful, is to jot down this distance formula. To be quite honest, you should know that by now. You shouldn't need to write it down, but just in case, there it is, where you take the difference of the x's, you square that difference, you add that to the difference of the y's squared, and then take the square root of that sum. That's the distance formula. Make sure you know that. Just looking through some things, actually you could probably just keep playing this as you're writing that distance formula down. The equation of a circle actually comes from this. If you have a circle here, which is the set of all points which are equidistant from this center point. Well, that common distance, that is the circle itself. That's the definition of a circle. If you take the difference, or I'm sorry, the distance between these 2 points, just some random point x, y, and where the center of that circle is, we'll call that hk, that distance is the radius. So if you use the distance formula with that information, then the difference of the x's will be x minus h squared plus y minus k squared. We add those two differences together, and then we take the square root of that. That is what the radius is equal to. That's the distance of the radius. So to get rid of this square root, then what we can do is just square both sides. We have this equation right here where r squared equals the quantity of x minus h squared plus the quantity of y minus k squared, and that is the equation of a circle. And as we see here, the equation of a circle with a center at hk with the radius of r is x minus h squared plus y minus k squared equals r squared. Putting that to use, if we have a circle, that's supposed to be a circle, J, with a center at 2, 2 and a radius of 4, then the equation of that would look like this. We would have x minus 2, that quantity squared, plus the quantity of y minus 2 squared equals 16. Okay? This 2 and this 2 came from, and if you just look at your notes of where you have the equation of the circle, yet the center is at 2, 2. So the equation of the circle would be x minus 2 squared plus y minus 2 squared equals r squared. So r is radius, that's 4. Square that, and the last time I checked, that is 16. So here, if we have the equation of the circle P with a center at 0, negative 3. Now, that would look like x minus 0 squared. However, we really, if you're just subtracting 0, you don't need anything there. So we could call that x squared plus the quantity would be y minus negative 3. Well, that makes that y plus 3 squared equals r squared. Now, 8 squared is, very good, 64. There you go. Questions? I'm not going to answer that one. Okay, so adding a little twist here, if you have the equation of this circle, circle K, that passes through the point 6, 4, so the circle's going through that point, has a center at 1, negative 8. Now we have enough information to do this. We can say that we have x minus 1 squared plus y minus negative 8, so that becomes plus 8 squared, equals, and the problem we run into here is we don't know what the radius is. So we're going to find that radius by taking the distance between J and K. So we need to find out what is that radius. I'm going to say r equals rather than d equals, and I'm going to use the distance formula. Alright, I'll do this kind of quickly here. I've got 6 minus 1, which is 5, squared, plus the difference of the y's, so 4 minus negative 8, that's 12 squared. Okay, I take that I take that sum, that's 25 plus 144, all right, which would be 169. All right, so the radius itself is the square root of 169, which is 13. The reason we found that is that we had to find what the radius is so that we can square that number to put it back into this equation. Therefore, if I square that 13, it's kind of like we're going back and forth here, just back and forth and back and forth and back and forth. If we square the 13, we get 169. So our equation would be right there. Underline that in red. So likewise here, if I have, let's go in blue this time. If we passes through the point 23 and has a center of 2, -1, you really want to watch for where the center is. Don't get that mixed up with the point that goes through. It has a center of 2, -1, so I have the center of 2, -1, x minus 2 squared plus y plus 1 squared equals the radius squared. So I'm going to find the radius by using the distance formula. 2 minus 2 is 0. Okay, that's good. Plus the difference of the y's, that's 4 squared. This would give me 16, so I'm taking the square root of 16. That's a 6, which is 4. Now don't forget I squared, this is an r squared value, so I squared this 4 to get 16. Really, once you get this number in here, you don't have to take the square root of it because that's the number that we're going to have right here. Finally, just real quick, putting this all together, if we were to graph one of these equations, then it's actually one of the easier graphs that you'll have to do. Where would the center of this graph be? No, not 3, -4. Right. Sorry. Let's try that again. Where would the center of this be? No, it's not at -3, 4. Right. 3, -4. So I'm going to go 3, -4. That's the center of this circle. Okay? What would the radius of this circle be? Nope, not 9. Oh, I'm sorry, I misunderstood you. I thought you said 9. No. Yeah, you're right, it's 3. The radius of this is 3. We take the square root of that 9. So what I'm going to do is I would actually just count 1, 2, 3 units here. Maybe put a little dot there. From the center, I'm going to go to the right 3. I'm going to go down 3. Just go in all directions. This is going to be possibly the ugliest circle ever known to humankind. And I'm kind of afraid to do this, but we'll try it. There is the perfect circle. Stop laughing. Well, those are your notes for the evening. Believe it or not, probably made it in one part there. I just flashed the assignment on there, but you don't need that right now. That's what you'll work on tomorrow in class, and we're probably looking at the quiz on Friday. Have a great night. Thanks for your everything. Just thanks for everything. Have a good day.